Here we go. Number 2. H is 15 degrees. F is 55.5. G is 64.5. Number 4. S is 62 degrees. R is 6.6. And side S is 7. Number 6. Angle D is 83 degrees. And side B is 12.8. And side C is 28.7. 8. Left about 20.1 feet. And right about 49.2 feet and 113 degrees. Number 10, B is 48 degrees. C is 24 degrees. And side C is 3.9. 12, angle B is 18 degrees. Angle C is 135 degrees. Side C is 27.8. 14, angle B is 14 degrees. Angle C is 21 degrees. Side C is 8.7. 16 is no solution. 18 is about 41 feet. 20, B, angle B is 52 degrees. Angle C is 102 degrees. Side C is 11.2. And angle B is 128 degrees. Angle C is 26 degrees. Side C is 5.0. 22, angle B is 84 degrees. Angle C is 49 degrees. Side C is 25.8. And angle B is 96 degrees. Angle C is 37 degrees. And side C is 20.6. 24, angle B is 30 degrees. Angle C is 132 degrees. Side C is 19.2. And B is 150 degrees. C is 12 degrees. Side C is 5.4. 26 is 18.3 miles. Excuse me. 28. Angle X is 11 degrees. Angle Y is 137 degrees. Angle Z is 32 degrees. 30, K is 23 degrees. L is 32 degrees. And side J is 50.7. 32, angle F is 38 degrees. Angle G is 52 degrees. Angle H is 90 degrees. 34, angle L is 131 degrees. Angle M is 15 degrees. Angle N is 34 degrees. 36 is 23.5 feet. 38 is 312.2 inches squared. 40 is 167.6 millimeters squared. 42 is 2,895.1 miles squared. 44A is 163.9 feet squared. 44B is 66%. 46 is 121.5 yards squared. And 48 is 119.4 meters squared. And 50 is 128.7 centimeters squared. So where do we want to start our questions? Okay. Number 6. Is triangle BCD. I don't know you. Go away. $30. And side C and side B. And angle 20. B is 25 degrees. Angle C is 72 degrees. So.
First, we just know 180 minus the.
Okay. 180 minus 97 degrees. Okay. So measure of angle. Wow. Angle D equals 83 degrees. Great. Now what?
We can do sine 50, which is 83 degrees, over 30. And then that'll equal, we'll do B first, I guess.
Sine of 25 degrees over side B. So B would equal 30 times the sine of 25 degrees over the sine of 83 degrees. And theoretically, when you punch that in, you get 12.8. Yeah. Depending on where your rounding is. And then you do the same thing with side C. Are you in radians on accident? Because if you're in radians, you'll get the wrong thing. That's entirely plausible. What else? Mm-hmm. It should be in like mode or setup or something. It's right there. Can I use the little mouse and click there? Oh. So there's probably some other way to do it, but you can use the little mouse and just click on it. Okay. There's probably some other way to do it, but that does work. Okay. 12. Yeah, let's do it. 12. Find all solutions for the given triangle if possible. If no solutions, write no solution. Round side lengths to the nearest tenth, angle measures nearest degree. Number 12, we are given A equals 18, B equals 12, and A equals 27 degrees. So if it were me, I would draw a little reference triangle because it's easier to think about. A, B, C, 27 degrees, 18, and 12. Then what would we do?
We can do the sine with A's.
Mm-hmm. So the sine of 27 degrees over 18 equals the sine of B over 12, right? So the sine of B equals, I'm going to split this because I'm having a hard time seeing it for some reason. I don't feel as foggy as I did the other day, but you know.
Can you just, instead of doing that, can you just apply 12 on both sides to get it off the bottom?
Yeah, it's the same thing. It's the same, you'll get the same thing. 2/3 times the sine of 27 degrees. So the inverse sine of 2/3 sine of 27 degrees equals B, right? And then you punch that in the calculator.
And when you're multiplying times the inverse sign.
You're not multiplying, you're doing the inverse sine of it.
Oh.
Oh. Yeah, so in the calculator, you'd punch inverse sine, and it'll give you parentheses, and then 2/3 times sine 27, and then close both parentheses potentially, depending on. What other questions do we have?
What's the answer? Is it 17.5?
What are we even doing? What is this, 12? 12, yeah, but it's 18 because it has to round them to the nearest degree, so. Yep,
Can we do 8?
sure.
I was so
Architecture.
architecture and we'll go in a pit. I don't know how to, like, where to put the givens, because it didn't, but it kind of did, but I wasn't sure.
An architect's client wants to build a home based on the architect John Lautner's Sheets Goldstein house. The length of the patio will be about 60 feet, and the left side of the roof will be at a 49-degree angle of elevation, and the right side will be at an 18-degree angle of elevation. Determine the lengths of the left and right sides of the roof and the angle at which they will meet. Okay, so YOLO, here we go. Let's see if we can figure out what all is happening in this problem. It does. Okay. So, the left side. Okay. So it's like a triangle roof, like this. The length of the patio will be 60 feet. So 60 feet. So 49 degrees and 18 degrees. This is how I would interpret what it's explaining. But we'll see whether the answer gives what the key matches what's the key and see whether our interpretation is correct or not. Okay, so determine the length of the left and right sides of the roof. Okay, so we need this one and this one. Call them A and B, why not? Okay, so we've got to subtract from 180. So we've got to get the one that's missing. 180 minus 49 minus 18. 113 degrees. So the sine of 113 degrees over 60 equals the sine of 18 degrees over A, right? So A equals 60 times the sine of 18 over the sine of 113. And we punch that in the calculator, what do we get? I should call this L and R. That would have made more sense, left and right. Oh well. 20.1 is what they're saying. Did we do it right?
That's what I got.
Okay. About 20.1 feet.
I don't know what I did the first time. I think I was so confused by trying to figure out how the building was set up.
Well, yeah. We just kind of had to a little bit YOLO what they meant by the descriptions. And then you do the same thing on the other one, right? So the sine of 113 degrees over 60 equals the right side, the sine of 49 degrees over the right side. So the right side would equal 60 sine of 49 degrees over the sine of 113 degrees. And we end up with, theoretically, about 49.2 feet.
Okay, that's what I thought. Maybe do 18.
Sounds fine.
Another word problem, yay.
Yeah, but this one has a better picture, so. A ski lift rises at 28-degree elevation during the first 20 feet up a mountain to achieve a height of 25 feet, which is the height maintained during the remainder of the ride up the mountain. Determine the length of cable needed for this initial rise. Okay, great. Let me give the sketch of this problem. Look, there's a right angle in there. That might be nice. We might be able to use just some regular trig to pop something out. Probably not, though. Probably it's just trying to throw us off and give us false hope. Probably.
I don't think that gray triangle is supposed to be part of it.
Yeah, probably not. So we've got these shape. And its initial angle is 28 degrees. 28 degrees. And it's going to be 25 feet up. And we want to figure out this cable. Yeah. Great. So we need to solve for x.
We know two of the sides. A is greater than B, so I know it's one solution.
Oh, we also know this is 20, right?
Yes.
That doesn't really matter though, does it?
It does matter.
Also, the 25 feet, I don't think it includes that.
Right, I agree. I think it's just the elevation from there. I agree.
Okay. So we know there's one solution, and I don't know the next step.
We know the 28 angle, that whole angle is 56 degrees.
We know what whole angle is 56 degrees.
28 is only half.
We don't know it's half of it.
We have A is sine 28 degrees over 25 feet.
We do have that.
Side B, not A.
Yep. So, yeah, we have that over 25, and we could say that equals the sine of whatever. A, sure, or B. We can call it B, it doesn't matter.
That one B, and then I had the ones that we had the numbers for.
The sine of B over 20. We could find that angle, which would let us get the other angle, right?
So we would do, it'd be 20 sine 28 over 25.
Sine of B equals 20 times the sine of 28 degrees over 25. So the inverse sine of, well, that could get reduced to 4/5. 4 sine of 28 over 5 equals B, right? And the angle we actually care about, C, or probably more like x, right, would equal 180 minus 28 minus the inverse sine of 4 sine 28 degrees over 5. Then we punch all of that in the calculator and push enter. And then we could do the sine of 28 degrees over 25 equals all of this, the sine of all of this mess over x, and then x would equal 25 times the sine of angle x, whatever we get for that, over the sine of 28 degrees. And we get about 41 feet.
Yep.
Great.
Uh, 22. What's my goal?
Two triangles, the given angle measure and side lengths. Round lengths to the nearest tenth and angle measures to the nearest degree.
This is where I really started to have issues.
Okay. Excuse me. 22, you said?
Yes.
Okay. So we have angle A equals 47 degrees. And side A equals 25, and side B equals 34. Okay. So the reason why you can get two triangles is this. So if I have an angle A that's, easier, just angle A that is 47 degrees, and this side is 25, and this side is 34, right? And I can get 47 in two different spaces, sorry. Distraction day. What am I saying? It's gonna be 25 over there, or the other one. An obtuse version of the same thing. Yeah, because this, yeah. Because this length could be 47. Yeah, there we go. So 47, which is not that, it's more like this. 47 degrees here. If I do 25 there, or if I take and flip the 25 over here, then I would have a different one, right? It would be the same length. So that's why there's two triangles. Because it could be this one, or it could be the one where this is longer and this is still only 25. And this is 34. And the reason why there are two is because it gives us these opposite sides ones. So we're looking for what the acute angle is and what the obtuse angle is, which would change these. Okay? All right. So, knowing all of that, let's start with an acute version. Right, let me put that back up here. So about 47 degrees, which is about right like that-ish. If this is shorter, 25, this is 34. If this is 25. So, what are we going to do? So, the sine of 47 degrees over 25 equals the sine of, call it B, yeah, it's B, yeah, B, A, and C, over 34. So the sine of B, now, I'll wait to say other words until it's more useful, equals 34 times the sine of 47 degrees over 25. Inverse sine, I'm sorry, too many things in my head. I'm writing too many things. Inverse sine of that equals B, yeah? Okay, so what did you get when you punch that in?
84 degrees.
84 degrees, okay. Which is about right here. Right? 84 degrees. Make sure we're tracking good. What number are we doing? 22? Yeah, 84 degrees. Great. So 84 degrees is one place where it could be. Now, we know from our other stuff that that sine, that it can have the same value in two different places. So where else is sine positive? Yeah, quadrant 2, right? So it can also be positive over in quadrant 2, which would have the reference angle of 84 degrees, right? So this reference angle would be 84. So what we need to figure out is how many degrees is the obtuse angle there?
So 180 minus 84?
Yes.
That would be 96.
It'd be 96 degrees. So there's one triangle where B is 84, and then there's another triangle where it could be a 96. Right? So then after that, it's just all the same stuff we've been doing, right? This is 84 or 96. And so you'd figure out what C is just by subtracting stuff from 180, and then just use regular law of sines to get the rest of the things.
Okay, that makes more sense now.
Good. What else?
Well, I didn't do anything past 24, so I need to do like example chunks.
We definitely should do some area ones if y'all don't have any other questions, because we didn't really do examples of those the other day. They're not hard, but because they're just pretty much just plug into the formula and go, but we should certainly do examples of them to make sure we know what we're doing. You have any other questions? Okay. Was in radians. Okay, so we should definitely do something from like 38 to 42. Let's see. And then we should also do something of the other kind of area problems, right? Yeah, okay. So let's do, how about number 40? Okay, so number 40, we're supposed to use Heron's formula to find the area of each triangle rounded to the nearest tenth. So this triangle, X is 37 millimeters. Y is 10 millimeters. And Z is 34 millimeters. Right? So we're supposed to use Heron's formula to solve it, which is what we need to use to solve it because we know the side lengths. Right? So what's Heron's formula?
That's the one with the big square root.
Mm-hmm. Area is the square root of.
What is S? Is 1/2 of
S is 1/2 of. It's in your notes, right?
I thought that was another part of the equation.
A plus B plus C. So let's find S first. So S would be 1/2 of 37 plus 10 plus 34. So 44 plus 37, 90 something, right? 40, oh, when you, yeah, 90 something. 44, oh yeah, 81. 81 divided by 2 is 40.5. Great. And then we just start plugging stuff in this other formula. The area is the square root of 40.5 times 40.5 minus 37 times 40.5 minus 10 times 40.5 minus 34. Easy money, right? So square root of 40.5 minus 37 is 3.5. And that'd be 30.5. And that would be 6.5. What's 40.5 times 3.5 times 30.5 times 6.5? Oi. 1,101. And then the square root of that is about, right in there's tenth, is that right? Somebody said? So 167.7 millimeters squared. Yep, easy money. Yeah, so let's do one of the other kind where we're not using Heron's formula, using our other method, our side angle side method. Ooh. So let's do, how about number 46? I don't know why I wrote degrees. 46 is L equals 67 degrees and side J equals 11 yards and side K is 24 yards. Okay. So this, I think it would be easier, although it's, I mean, it's maybe obvious what you would do, but I think it's easier to see and think if you like draw a little picture real quick. So L. So L is 67 degrees. Obviously my picture isn't even to scale, it's just reference for the brain getting how the triangle's set up. right? So what is the formula we're going to use to find the area of this?
1/2 BC sine A.
Yeah, equals 1/2 BC times the sine of A, which in this case would be 1/2 of,
That's 11 times 2.
yeah, 11 times 24 times the sine of 67 degrees, right? So 12 times 11 is 100 and whatever, 30 something, 132, is that right?
What did it do?
1/2 times 11 times 24. 12 times 11, 132.
132.
Yeah.
And then times 67.
Sine of
121.5 yards.
110. 121.5, yeah. 121.5 yards squared. Easy money. Okay. That's it for that lesson. That's really all there is. It's no big deal. So what we should do with the remainder of our time is jump over to the practice test and see if y'all have any questions that you want to look at from there. How are all the animals doing? Sorry to wake you up. I didn't mean to be loud.
I just fell asleep with you guys.
I figured that would probably happen. Yeah, you mean the easy ones?
Yes, because I have to do them.
Okay. All right, sure. Number 2 from the practice test. So this is page, whatever it is, 307.
Climb over from his perch. So he had to go away.
Uh,
And he got really mad when I tried to take him away. So I was like, you have to go back to your house.
Poor window. Number 2, we've got a triangle that looks like this with a 33-degree angle, X right there, and 11 right there. What trig function are we interested in at the moment?
The side thing.
What is 11 to it? Opposite, adjacent, opposite, and adjacent. So which one is opposite, adjacent?
Tan.
So the tangent of 33 degrees equals 11 over x. By x on both sides, we end up with x equals 11 over the tangent of 33 degrees. If the instruction said leave your answer in exact terms, you would circle it. But since the answer says round to the nearest tenth, you're going to shove that in your calculator, push enter, and you'll get 16.9.
This is the no calculator portion, okay?
This would not be. This would, no, not with the, if it said 30 degrees, it certainly could be.
So which on here is going to be the no calculator?
Which on here is going to be the no calculator portion. So things like 6 and 7 could certainly be on the no calculator portion. Things like 9 and 10 could certainly be on the no calculator portion. Things like 11 and 12 could be on the no calculator portion. And
And this test is Thursday, right?
it is Thursday. And things like 23 and 24 could be on the no calculator portion. And if I felt like it, I might throw in something like 13 on the no calculator portion, although the calculator wouldn't help you with 13. So that could show up either way. But a calculator won't help you with it, so. All right, what else should we look at? Which trig function is being used in number 4?
Cosine?
Cosine. So the inverse cosine of 8 over 18 equals theta. And you get 64 degrees. About. Oh, I'm sorry. 6 and 7 wouldn't necessarily be on the no calculator portion. That's just converting degrees and radians. It's simple math, but it wouldn't necessarily be on the no calculator portion. You certainly will have area of a sector problems. You have like all this stuff. It is very likely you will have one word problem. That's very probable. If we do a word problem, it'll be something like I'd be tempted to do that, but no, it won't be something like that. I'm going to look for a good example of a word problem that I'm not seeing in the study guide. Let me flip back a few pages. Probably if you had one, it would be maybe you won't have a word problem. I was thinking that there would be a physicsy type problem, but maybe from lesson 1. Let me look. Yeah, if you had a word problem, it would be something like 27 to 30 on page 227. If you have a word problem, it'll be something like that.
Which problem?
27 to 30, it'd be something like one of those where you have to, where it's fairly basic trig. You just got to pull out stuff from there and then do the simple math. That wouldn't be on the no calculator portion. And it'll have units, whatever it is, if it's there. What other questions do we have? In practice test or study guide or any of these other things? You will certainly have a couple graphs. That will definitely be true. I will guarantee you'll probably have one that's either sine or cosine and one that's something else. Probably won't be cotangent because I don't like cotangent. I think it's dumb. But tangent or secant or cosecant certainly could have a graph of one of those. You won't have any graphs of inverses. We omitted that portion. You'll have to calculate inverses, and most likely it'll be on the no calculator portion. You won't have like on 305, number 60, or 59 and 60, you will not have something like that where it's a nested one. They're not actually much harder, but you will not have one like that. You will certainly have one like or more than one, like 53 to 58. Certainly have that. The graphs will be real similar to stuff from that lesson. Probably won't have more than 2 transformations in one problem. Honestly, probably won't have more than one, or 37 to 44, yeah. If there is more than, on the other trig function, it'll probably just have one transformation. So it'll be more like 45 or 47 or, yeah, 40, it'll be like 45 or 47, something where there's just one thing that changes. On the sine cosine, it could have a couple of things. So something like 44 or 43. Well, 41 through 43 actually.
Will it have linear or angular speed stuff?
Let's see, what lesson was that? That was lesson, you will likely have an area of a sector problem, but you probably will have a linear speed aid. Probably it'll be like number 5 on the practice test, something like that. It won't be multiple choice like number 5 because I don't do that, but it'll be something like that, where you just have to use the formulas. What is in? Well, let's gather some formulas. So what is the linear speed of a point rotating at an angular speed of 36 radians per second at a distance of 12 inches from the center of rotation? So we've got some wheel turning, right? That's what's going on here. So we've got a wheel spinning. Looks kind of like this, more or less. And it's got linear speed. And it's got angular speed, how fast this is spinning around, and whatever else. So, what formulas do we have for these things?
V equals T, and then the W looking thing equals theta over T.
V equals ST, and there you go, equals what?
Theta over T. The top one is S over T, not S times.
All right, so what are all of these letters? Let's see if we can collect some of that information.
S is the arc length.
Arc length.
T over this time.
Time. There's also time over here. Not Tim, but time.
Theta is the angle.
Angle. Has to be in radians, right? And this is angular velocity, right? Okay, so see what all we have from this problem. We have, what is the linear speed? So we're looking for V. Of a point rotating at an angular speed of 36 radians per second. 6 radians per second. At a distance of 12 inches from the center of rotation. So the radius is 12 inches, right? Okay.
36 radius in a second.
How do we figure out how far it traveled? How do we figure out this length? Because this is S, right?
Yes.
So we need to be able to figure. We need to figure out S.
Is the angle 36 radians?
Mm-hmm. We need another form. We need to collect another formula. We need to figure out did we not ever miss? Isn't there a formula that goes back and forth between the two? Where's the? Isn't there one more formula? Are we missing one?
Back and forth between radians and degrees?
No, no. Yes, there is a formula for that, but that's not what I was. That's not what I was asking. Or mumbling. I wasn't really asking anything. I was mumbling about. Which lesson is that in? 2, probably.
Find the length of an intercepted arc in a circle with the given central angle, measure, and radius. So.
What is 36 times 12?
S
Yeah.
equals radius times theta. Where theta
Yeah.
is measured in radians.
Yeah, yeah,
That's
okay.
full enough.
We don't even need like 90% of what's up here. Okay, so, yeah, I was right. Okay, great. So, to find the arc length, what's the formula for arc length? So this S.
S equals radius times theta.
S equals radius times theta. And S also is the same amount of that much traveled. So S equals 12 times 36, which is 432.
And then we
So 432, what is the units? It's inches per second in 1 second, because that's in 1 second. Velocity also, oh yeah, equals S divided by time, because the time is still 1 second. Yeah. Yeah. Great. Easy money. I think it's about time to quit, y'all. If y'all want the answers to the practice test or the study guide or any of those things, just send me a message and I will send them to you.